This working? Yeah. Cool. Hello, everyone. Thank you for being here. This is Jordi from Vocdoni and my colleague Pau. We are very happy to have the opportunity to present it here. So today we are going to introduce DAVINCI, which is an end-to-end verifiable, anonymous, receipt-free, and decentralized voting protocol engineered for mass adoption. And everything is fully secured by ZK snarks. So before entering deep into the DAVINCI, I want to talk about Vocdoni, where we came from, and all the things that we have been doing. So what is Vocdoni? Vocdoni is an open source digital voting project that leverages distributed technologies and cryptographic to deliver secure and transparent decision-making processes. So we have the vision to improve democratic and participatory governance using decentralized and open source technology. And we have gathered around values of digital sovereignty, open source, public goods, and tech for good. So where we are, so who we are and where we came from. So we were born in 2018. We were led by a multidisciplinary group of pro-democracy activists, and we were in a context of state repression against the Catalan civil society that was running a referendum about self-determination. And at that point, we realized that current voting systems are opaque, are centralized, and are super costly. Also, we have that the voting is an exclusive asset, so this voting thing is controlled by nation states, from the census and all the infrastructure. If you think about organizing a voting process in your country, you don't even know where to start, because you don't have the tools. So the idea from Vocdoni is to create an unstoppable voting system and to democratize decision-making to any citizen. Okay. So doing a brief on our tech evolution. So we started in 2018. We did a fork of Zcash because Zcash had the properties of privacy, and we held a voting process with 2,000 people. It was super nice because people didn't even realize that they were using blockchain technology. But yeah, at that point we realized that going with Zcash, it was a limited solution because lack of programmability. So then in 2018, at the very end of the year, we tried to build a custom Ethereum proof of authority network, but there was an scalability problem, and we were missing the cryptographic primitive that we were looking for. And then finally, in 2019, we built a custom term-determined blockchain, which is basically a state machine that counts votes and held all the voting process and so on. And nowadays, it's still being used. It's using Circom and Snark.js on the client side for the voter to encrypt their vote and to provide anonymity. And yeah, as I said, it's been running. It's still being used by more than 200 organizations. And we are very happy about it because we can provide a really nice UX. So Vocdoni is based on using Web3 technology to provide solutions to the Web2 world. So people doesn't need to deal with with accounts, with all the transactions and so on. So everything is transparent to the user. Even my grandmother can use it. And then we were in 2024. We revisited the Ethereum ecosystem. Scalability was not an issue anymore, and we had the cryptographic primitives for building what we are going to announce today, which is DAVINCI.vote. And yeah, I think it's also important to highlight some of the use cases that we had. On 2024, we helped the Belarusian opposition on holding their elections in a context of high censorship and suppression of the voters. We had some international visitors to check that the process was properly done and so on. And also talking about different verticals, we've been providing solutions to political parties in Spain, like Escrich Republicana, which is holding like high-stake votings. For example, they decide to invest or not the current president of Spain. So their member base used our solutions for doing so. Also, we also provide some solutions to Omnium Cultural, which is the largest cultural organization in Europe with more than 180,000 members. And we also supported Football Club Barcelona elections and some other sport clubs. And it was there's another use case that I want to highlight, which is this one, which is the Bell Puig. It was the first legal binding referendum held in Spain with all the democratic guarantees. It was under COVID restrictions, and it was super cool to see people to vote without even leaving their house. And we also provide a QR code, so people that is not familiar with electronic devices and so on can go to a polling station and vote using the QR code. And well, we are also providing the solution to unions and professional colleges. For example, in this case, we provide the solution with a two-factor authentication mechanism via SMS and email to the official College of Nurses in Barcelona. And yeah, I don't want to extend a lot more on this, so I will pass the ball to Pau, who will be talking about the technological intrinsic of DaVinci. Thank you.
Thank you, Jordi. Sorry for going so fast. We only have 12 minutes, and we want to communicate a lot of things, so let's go. Let's talk about DaVinci, which is this next evolution for our voting protocol. It's fully based on zk-SNARK. DaVinci is an acronym that means Decentralized Autonomous Vote Integrity Network with Cryptographic Inference. So this quite describes what the protocol is. It's decentralized and autonomous as DAOs, so it doesn't rely on a central authority or central point. We as Vocdoni can disappear and this should be running. It's a vote integrity network, so that's the main objective for everything. We are processing votes, verifying, aggregating in batches, and then uploading them on-chain. And it uses cryptographic inference, meaning that we derive conclusions exclusively from cryptographic primitives. So from the beginning to the end, everything is cryptography, and everything is ZK. Let's deep into the architecture. It's complex. I mean, we have a white paper of 30 pages, I think, at whitepaper.vocdoni.io if you want to know the details. I'm gonna try to make a brief, too long don't read. So we have three main actors, which are voters, sequencers, and the Ethereum blockchain. And then we have the state. The state is a Merkle tree, and the state root, which is the Merkle root of this Merkle tree, lives on Ethereum. So the only information that we store on Ethereum is this state root and then some other minor parameters. This allows us to cast votes and to process voting with a very low gas cost. Then sequencers, there is a network of sequencers that are constantly batching and processing and verifying votes and making this state to transition to the next state. So they generate a ZK proof proving that the state transition from the current root to the next one is correct. And then the new state contains the new votes from the batch and also the results which use homomorphic encryption and so on. So to create a voting, the user or the creator of the voting needs to send a transaction to Ethereum to start to bootstrap everything. This transaction contains the census, which is a list of addresses and weights. So this adds a lot of flexibility to the solution because anyone can build a census and it doesn't matter what kind of information you are using or even with what kind of source of this information are you using. So only the census root of this census is going to Ethereum as part of the initial state. Then the sequencers will strap an MPC to create the threshold encryption key. And this key will be used for encrypting the votes. And at the end, the sequencers will run another MPC coordinated always through Ethereum and ZK proofs in order to decrypt the results. Right? So the voter wants to send a vote. A vote is mainly the vote itself, which is encrypted using this encryption key, and then a ZK proof that proves the integrity of the vote, so it has been correctly encrypted, following the rules of the protocol. For instance, if I have 3 options to choose, I cannot choose the 4th option, right? So this is proven inside the zk-SNARK. And finally, an Ethereum signature that can be performed with any compatible signer, including Trezor, ledgers, and so on. And so this process is happening all the time. Sequencers are accumulating votes, putting them in batches, modifying the state, updating the state, and so on. And many sequencers can work in parallel. So this allows us to decentralize the whole system and to scale horizontally. And talking a bit more about the specific implementation that we have done, this is already working. So today we are announcing that we are publishing the first testnet and MVP for all this protocol. We have been working the last 8 months on this. It's currently using Circum in the browser for the first circuit, and then we have 3 more circuits. All of them are chained, so the first one is verified by the second, and so on, until it reaches to Ethereum. And for the sequencer backend, we use GNARC. GNARC because it's low level, so we can apply optimizations to the code, and it's not like a zkVM where it's hard to access to the low-level operations. And because GNARC supports many curves, and there are 2 special curves, elliptic curves that are cyclic, so they allow to have native aggregation or recursion. So this is how we aggregate many votes in a single batch, and then the batch is sent to Ethereum, and so on. This process is repeated all the time. These are the numbers of the current implementation. I'm pretty sure we will improve them. It's the first implementation, and there is still room for optimization. But right now, it's usable. The numbers are quite good, and especially they can be executed using a CPU-only device. So we don't need GPUs. And this is also a very important property for us because we want to allow anyone to participate on this sequencer network. So the more sequencers, the more resilient and decentralized is the network. And that's the point.
Perfect. Thank you so much, Pau. So yeah, we wanted to do a live demo, but we are running short of time. So we have set up a voting for choosing the FCC best pizza. You can go to scc.davinci.vote and you can vote with your wallet. If you had a wallet with activity in the past 90 days, so you can vote, and hopefully your vote will be anonymous and it won't be coerced, and yeah, with all these nice properties that we achieved. Another thing, I forgot to mention it, it's a quadratic voting, so we have something called the ballot protocol that allows to create any kind of voting process you imagine, any kind of algorithmic you want on top of it. So yeah, that was all. If you have any question, feel free to reach us. Email, Telegram, we will be around the FCC. If you want to talk a bit more on the intrinsics of the protocol, please contact us and we can cross paths. I don't know if you have any question, and thank you so much for being here. Please. Okay. Now we can take the question on the other side. Thank you so much.
But hopefully you can catch him afterwards.